Let's take up this question using stock notation. Represent the following compounds. Let's apply the rules to calculate the oxidation number of desired element in the compound. HAuCl4, Au has oxidation number 3 because hydrogen has +1 and 4Cl will have -4. In Tl2O, oxygen has -2, so Tl2 will have Tl will have +1 oxidation state or oxidation number. In FeO, oxygen has -2, so iron has +2. So Fe has 2 oxidation number. Fe2O3, Fe has 3 and oxygen has -2. So 2x minus 6 equal to 0. 2x is equal to 6. X is equal to 3. So Fe has +3 oxidation number. In CuI, x minus 1 equal to 0, x is equal to 1, Cu has +1 oxidation number. CuO, x minus 2 equal to 0, x is equal to 2, copper has 2 oxidation number. In MnO, x minus 2 equal to 0, x is equal to 2, Mn has 2 oxidation number. MnO2, x minus 4 equal to 0, Mn has +4 oxidation number. Now how to write in stock notation HAu3Cl4, Tl2 1, in Roman we write oxide, Fe2O, Fe2 oxidation state is 3 which we write in Roman O3, oxidation number 1 we write in Roman of copper, here copper is in +2 so we write 2 in Roman, MnO we write Mn +2 that is 2 in Roman, and Mn4 we write in Roman in MnO2. Next question, justify that this reaction is a redox reaction. Identify the species oxidized, reduced, which acts as oxidant and which acts as reductant. First we assign the oxidation number to each species. This is cuprous oxide, copper has got +1 and oxygen has got -2. Here cuprous sulfide, copper has +1 and sulfur has -2. Copper in elemental form has oxidation number 0. In sulfur dioxide, sulfur has +4 and oxygen has -2. Here we can conclude that in this reaction, copper is reduced from +1 state to 0 oxidation state. +1 to 0 is reduction. So Cu2S is acting as reducing agent. So Cu2O is getting reduced to copper. And sulfur is getting oxidized from -2 to +4. Because here oxidation and reduction both take place simultaneously, therefore it is redox reaction. Further, Cu2O helps sulfur in Cu2S to increase its oxidation number, therefore copper 1 an oxidant, that is Cu2O is an oxidant, and sulfur of Cu2S helps copper both in Cu2S itself and copper oxide to decrease its oxidation number. Therefore, sulfur of Cu2S is reductant, or we can say that Cu2S is reducing agent. Next, we are taking types of reaction. There are 4 types of reactions: combination reactions, decomposition reactions, displacement reactions, disproportionation reactions. Displacement reactions are of 2 types. One is metal displacement reaction, second is non-metal displacement reactions. First, we are taking combination reactions. When 2 elements combine to form single compound, it is called combination reaction. For example, A plus B reacts to form C. Carbon solid reacts with oxygen gas to form carbon dioxide gas on burning or heating. Carbon has oxidation number 0. Oxygen has oxidation number 0. In CO2, carbon has oxidation number +4. Oxygen has -2. Magnesium reacts with nitrogen to form Mg3N2. Magnesium has oxidation number 0. Nitrogen has oxidation number 0. Magnesium ion has got +2 and nitride ion has -3. In CH4, carbon is -4 because carbon is more electronegative than hydrogen. Hydrogen has +1 oxidation number. Oxygen has 0. Carbon has +4 in CO2 because it is less electronegative as compared to oxygen. Oxygen has -2 and 2 water. Hydrogen has +1 and oxygen has -2. These reactions are redox reaction because the oxidation number is increasing as well as decreasing. Carbon oxidation number increases from 0 to 4. oxygen oxidation number decreases from 0 to -2. Here magnesium is changing from 0 to +2 and nitrogen is changing from 0 to -3. Here carbon is changing from -4 to +4, whereas hydrogen is changing from +1, oxygen is changing from 0 to -2. Hydrogen remains +1 in both the sides. Next we are taking decomposition reactions. We will also find out these decomposition reactions are redox reactions or not. How to find out these decomposition reactions or redox reactions or not? We will check whether change in oxidation state is taking place or not. 2 water liquid on decomposition gives 2 hydrogen gas plus oxygen gas. Now what are decomposition reactions? When one compound on heating decomposes to 2 or more elements or compounds, it is called decomposition reaction. Here hydrogen is +1 and here hydrogen is 0. So hydrogen oxidation state is decreasing from +1 to 0, whereas oxygen is increasing from -2 to 0. So it's a redox reaction. In second reaction, sodium hydride is decomposing to sodium metal and hydrogen gas. Sodium +1 is changing to 0 and hydrogen -1 is changing to 0. So this is the redox reaction. In KClO3, potassium is +1, Cl is +5, oxygen is -2. In potassium chloride, potassium is +1, chlorine is -1. And in oxygen, O2, 0 is the oxidation state. So +5 is changing to -1 means it is decreasing. Whereas oxygen is becoming -2 to 0, it is increasing. So increase and decrease in oxidation number means it is a redox reaction. And CaCO3 is decomposing to calcium oxide solid and carbon dioxide gas. Calcium is +2 in both the sides. Carbon is +4 here and +4 here. It is both the sides same. Oxygen is -2 and here also it is -2. There is no change in oxidation number taking place. So it's not a redox reaction. Displacement reactions. When one element displaces, a more reactive element can displaces less reactive element from its salt. It is called displacement reactions. First we are taking metal displacement reactions. Vanadium pentoxide solid reacts with calcium to form vanadium plus calcium oxide. Now it is a redox reaction or not, we have to check the change in oxidation state. Vanadium is becoming +5 to 0, decrease. Oxygen is -2 to -2, it remains the same. Calcium is increased from 0 to +2, so it's a redox reaction. Titanium +4 is changing to 0 and chloride ion -1 remains the same. But magnesium is changing from 0 to +2, so it's a redox reaction. In chromium trioxide, chromium is +3 and here chromium is 0. Here aluminium is 0 and here aluminium is becoming +3. So change in oxidation number, that is increase and decrease, both are taking place. Therefore, these reactions are metal displacement reaction as well as redox reactions. Now we are taking another example of displacement reactions, metal displacement reaction. Copper sulfate solution, which is blue in color, is reacting with zinc solid, which is gray in color. It forms copper solid, which is brown in color, and zinc sulfate aqueous solution, which is colorless. Here we are showing copper sulfate solution, which is blue in color, and we have added zinc rod in it. Here copper metal get deposited, which is brown in color, and the color of copper sulfate is becoming colorless slowly, and ultimately it will change to colorless. Here copper ions react with zinc to give copper solid and zinc ions. That is, copper ions are gaining electron to form copper solid. Zinc is losing electron to form zinc ions. So here oxidation and reduction both are taking place. Therefore, this is displacement reaction as well as redox reaction. Non-metal displacement reactions. 2 sodium metal reacts with 2 cold water to form sodium hydroxide plus hydrogen gas. Now hydrogen is being displaced, therefore it is called non-metal displacement reaction. Oxidation number of sodium is changing from 0 to +1 and oxygen is changing from -2. It remains -2 in both the sides. Hydrogen is changing from +1 to 0. Calcium is changing from 0 to +2 and hydrogen is changing from +1 to 0. So calcium reacts with water to form calcium hydroxide plus hydrogen gas. They also show that sodium and calcium are more reactive than hydrogen and can displace hydrogen from water. Less reactive metals like magnesium and iron react with steam to produce dihydrogen. Hydrogen is also called dihydrogen. Magnesium solid plus 2 water liquid, it should be hot water, heating has to be done. Then only reaction will take place and we will get magnesium hydroxide solid plus hydrogen gas. Here magnesium is oxidation state changing from 0 to plus 2 and hydrogen is changing from plus 1 to 0. Oxygen remains the same, minus 2 on both sides. So it's a redox reaction because increase and decrease in oxidation number is taking place. Iron reacts with steam to form Fe3O4. Fe3O4 is mixed oxide FeO into Fe2O3. Therefore, it is also called ferrous ferric oxide. Here, oxidation state of iron is 0, and here it is changing to plus 3 as well as plus 2 because it is ferrous ferric oxide. Hydrogen is changing from plus 1 to 0. So these are also redox reaction as well as non-metal displacement reactions. Many metals, including those which do not react with cold water, are capable of displacing hydrogen from dilute acids. Dihydrogen from acids may even be produced by such metals which do not react with steam. Cadmium and tin are examples of such metals. A few examples of displacement of hydrogen are given below. Zinc solid plus 2HCl aqueous gives you ZnCl2 aqueous plus hydrogen gas. Zinc is changing from 0 to plus 2, hydrogen is changing from plus 1 to 0, so it is displacement reaction as well as redox reaction. Magnesium is changing from 0 to plus 2, whereas hydrogen is changing from plus 1 to 0, it's redox reaction. Fe solid reacts with 2HCl to form ferrous chloride plus hydrogen gas. Here iron changes from 0 to plus 2, whereas chlorine changes from minus 1 to 0. So this is also non-metal displacement reaction as well as redox reaction.